Not coincidentally, though not intentionally either, Adam Higginbotham, the author of Midnight in Chernobyl, the untold story of the world's greatest nuclear disaster, conveys the delivery of Legasov's truth like that of a campfire story. Legasov's delivery was masterful, speaking uninterrupted for 5 hours through translators. The academician held his audience spellbound. He outlined the design of the reactor in detail, acknowledging certain drawbacks, but glossing over inconvenient facts, and described a minute-by-minute reconstruction of the accident sequence, far more terrifying than any of the Western experts had imagined. Higginbotham then proceeds to clarify. Pressed by reporters on the disadvantages in the reactor design he had mentioned, Legasov replied, "The defect of the system was that the designers did not foresee the awkward and silly actions by the operators." Most people assume that Valery Legasov was merely hiding or downplaying reactor flaws, like the positive scram effect, and that the actual truth he delivered at the Vienna meeting of 1986 was the spooky story he told to an enraptured audience of international experts, gathered to hear how the worst nuclear energy disaster in history was really about the fantastical mishandling of a reactor by quickly disposable operators. As you can tell, the point of this story matches the premise of HBO Valery Legasov's summation of the disaster. Dyatlov broke every rule we have, and pushed a reactor to the brink of destruction. But in the circumstances he created, it was the idiocy of the operators, and in particular that of Anatoly Dyatlov, as has been passed down to us, that accounted for most of the disaster. They say in academia, one of the most prized things is concise writing. We have a wonderful example of it on pages 22 to 23 of the Soviet report submitted to the Vienna meeting, tidily summarizing the essence of why the disaster occurred under a section called Causes of the Accident. In the first paragraph, Soviet experts informed their international counterparts that they knew about the positive void coefficient of reactivity, and designed the reactor facility to protect against it. For the much uglier reality, you can watch The Forgotten Truth of the Coefficients video, or check out the second pre-Chernobyl history video that in our opinion covers the actual causes of the Chernobyl disaster. In the following few paragraphs, Soviet experts explain that the reactor facility included both technical means of protection and strict rules and instructions for operation. Ultimately, the staff switched off a number of important protection systems and violated the most important provisions of the operating regulations for safe management of technological process. On the following page, we get a thesis statement. The designers of the reactor facility did not provide for protective safety systems capable of preventing an accident in the combination of circumstances prevailing in Unit 4, namely the deliberate switching off of technical protection systems coupled with violations of the operating regulations, since they considered such a conjunction of events to be impossible. Thus, the prime cause of the accident was an extremely improbable combination of violations of instructions and operating rules committed by the staff of the unit. The accident assumed catastrophic proportions because the reactor was taken by the staff into a non-regulation state, in which the positive void coefficient of reactivity was able substantially to enhance the power excursion. According to the Soviet report to the Vienna meeting of 1986, Chernobyl occurred due to a multi-step dismantling of reactor protection systems and violation of core rules and instructions by the operating staff. So insane, Soviet nuclear power experts simply could not anticipate and consequently prevent the extremely improbable, willful sequence that unfolded. The masters of weaponized narration took the Swiss cheese model of disaster and weaponized it. The Soviet Swiss cheese model of disaster takes substance in the table of most dangerous violations. It is this table that is supposed to contain the actual series of offences that render operators primarily responsible. It is our recommendation that the first thing anyone does in trying to understand Chernobyl is to read merely the following 7 pages. pages 22 and 23 of the Soviet report to the Vienna meeting of 1986, titled Causes of the Accident, pages 10 to 12 of an INSAG 7 section, ironically titled The Accident, as well as pages 13 and 18 of INSAG 7. All readers should be able to grasp what sort of accident we're dealing with here. Let's get started on analysing the table. Violation number 1 is the most familiar one, reducing the operational reactivity margin substantially below the permissible value. This is the minimum control rods to keep in the reactor core violation. We begin with Soviet experts having an awful lot of trouble identifying what the minimum permissible value actually was. 2 paragraphs above the table of most dangerous violations of the operating rules committed by the staff, we see the following sentence. Among the most important regulations are stipulations referring to the inadmissibility of reducing the operational excess reactivity margin to fewer than 30 rods. If we scroll up to page 8, we find another mention of 30 rods. An important physical characteristic from the standpoint of reactor control and safety is a quantity known as the operative reactivity margin, or excess reactivity. This is defined in terms of a certain number of CPS rods inserted into the core in the region of high differential worth for fully inserted rods. The excess reactivity for RBMK 1000 reactors is taken as equivalent to 30 manual regulating rods. The best mention we find of 30 rods is in Chernobyl, a Canadian perspective, where the authors relay this golden nugget. The Soviets said their procedures were very emphatic on that point, and that not even the Premier of the Soviet Union is authorized to run with less than 30 rods. What the Soviets say and what the Soviets do are 2 very different things. Even the Soviets themselves have difficulty squaring. On page 19 of the Soviet report, we find this tell. At 122.30, the excess reactivity was only 6 to 8 rods. In other words, not more than half of the minimum permissible value laid down in the operating regulations. If the minimum permissible value laid down in the operating regulations was 30, one would conservatively write 6 to 8 is no more than a third of that. Not no more than half when the value is basically a quarter. Let's hop over to a location where the Premier of the Soviet Union himself was present to get some clarification. On the 3rd of July 1986, the Soviet Politburo assembled for a key session anchored by the Government Commission report Comrade Leader Gorbachev was concerned about in the previous video. The speaker presenting its findings was Deputy Chairman of the USSR Council of Ministers, Boris Shabina. On the matter of the lower ORM limit, Shabina says, a most egregious violation was also the absence of the necessary operational reserve of reactivity in the reactor at that time. The regulation had already been violated during the morning of April 25th, when the reactor was working with a reserve of only 13 control rods, instead of the minimally allowed 15 rods. Operating the reactor with less than 26 SUZ, which is the control and protection system, control rods can only be permitted by the chief engineer of the station. So, less than 2 months later come the Vienna meeting, the Soviets were lying. INSAG 7 cites the operating instructions as stating that 26 to 30 rods was apparently the minimum at steady high-power operation. The reactor could be operated with less than 26 rods upon authorization of the chief plant engineer, and the actual minimum ORM was 15 rods. If we scroll down 1 page, we find this very curious note. The design documentation also contains equally contradictory directives concerning the ORM. For example, in reference 44, it is stated that, at rated power during steady-state operation, the ORM should not be less than 26, and not more than 35 manual control rods. On the authorization of the chief plant engineer, a reactor may be allowed to operate with an ORM below the minimum value, but for no longer than 3 days. Operation of the unit is not permitted at an ORM of less than 10 rods. The source for this bizarre mention of an ORM lower limit of 10 rods dates to 1983 and was approved by both Nikiet, the chief design engineer of RBMK reactors, and the Kurchatov Institute of Atomic Energy, or the chief scientific manager of RBMK reactors. Contradictory directives aside, what about operational realities? Here we have the shocking statements of the 25th of April 1986 Chernobyl Unit 4 morning shift supervisor Igor Kazachkov. Why didn't I and my colleagues turn off the reactor when the number of protective rods decreased? Yes, because none of us imagined that this was fraught with a nuclear accident. We knew that we shouldn't do this, but we didn't think. Nobody believed in the danger of a nuclear accident. No one told us about this. There have been no precedents. I have been working at nuclear power plants since 1974. I have seen much more cruel regimes here. And if I turn off the device, I've washed my withers very well. For this reason, by the number of rods, we have never had a block stop. And if you stop the reactor while reducing the stock of rods below the permissible, what would you be? I think they would be kicked out of work. Would definitely get kicked out. Not for that, of course, but they would find fault with something. This parameter, the number of rods, was not considered serious in our country. By that parameter, by the way, there was no protection from the fool, and still no. There are a lot of protections, but there are no rods in terms of quantity. I will say this, we have repeatedly had less than the permissible number of rods, and nothing. Nothing exploded, everything went fine. How could such a terribly important parameter have been routinely violated by RBMK operators in general? How about because it literally was not labelled as an important parameter? The ORM is not included in the list of important parameters. There wasn't even a device measuring it reliably. Unsurprisingly, it was not associated with either an alarm signal to get the attention of operators, or with an automatic emergency protection trip. It is well known that both the information and report presented by the USSR State Committee on the Utilization of Atomic Energy to the IAEA identified the main personnel error as operation of the reactor with an ORM below the established limit. However, the design documentation and research work conducted to analyze the design made no provisions for the ORM to be treated as a parameter which would trigger the alarm system or the EPS, Emergency Protection System, when it reached the limit value. Only after the accident, in the summary of measures to improve the safety and reliability of nuclear power plants with RBMK reactors in operation or under construction, was mention made of the development of an ORM recorder with a display on the control board, and an instrument to produce an emergency signal to shut down the reactor if the ORM reached the emergency trip point. If the ORM was actually intended to be a parameter governing the integrity of the emergency protection system, it would have been illegal for the designers and scientists overseeing RBMK reactors to have given operators full control of it. Thus, the ORM is not regarded in the operating procedures as an indicator of the ability of the EPS to perform its functions. This is natural, since such an understanding would be regarded as an unlawful transfer of reactor protection functions by designers from engineered safety features to the personnel, and to its ability to work in the plant computer operating mode. See note to section 4.7.1 of this report. The design documentation also did not treat the ORM as a critical parameter requiring a protection system. See sections 3.3 and 3.7 of this report. The RBMK was the only reactor type that had a lower ORM limit, and calculations to determine how reactivity insertion depended on it were done only after the disaster. Page 39 of INSAG 7 explicitly brings up the timing of the research, and accordingly the apparent ignorance of designers and scientists, as will become a clear theme of what the masters of weaponized narration wrought. They basically took what they learned or did after the disaster and applied it pre-disaster to make it seem like the operators were the idiots who blew up the reactor. The ORM controversy reaches its apogee when we zero in on the period immediately preceding the disaster. The strong possibility emerges that the value of 6 to 8 control rods associated with the disaster is yet another Soviet expert trick, it being a transient ORM minimum that occurred a few minutes before the disaster with no effect on it. The value of the ORM that actually affected the disaster appears to have been significantly higher, perhaps high enough to equal the permissible minimum of 15 rods. For a long discussion on this topic, refer to the unanswered questions, how many control rods were in the core when AZ5 was pressed video. The table of violations used against the operators has a consequences column that contains critical insights to the Soviet deception. The consequence to the first violation is listed as emergency protection system of reactor was ineffective. The word ineffective is very meaningful. Soviet experts tried to conceal the role of a positive scram effect in the reactor's destruction. Based on data they disclosed, however, eventually some Western analyses publicly postulated the effect. The Soviets subsequently fessed up in 1987, and the positive scram effect gained prominence. Most analyses now associate the severity of the accident with the defects in the design of control and safety rods in conjunction with the physics design characteristics, which permitted the inadvertent setting up of large positive void coefficients. The scram just before the sharp rise in power that destroyed the reactor may well have been the decisive contributory factor. In other words, the emergency protection system, or simply the shutdown button, was not ineffective, but destructive. This lie will have a knock-on effect on other Soviet expert lies that only made sense in the absence of a decisive positive scram effect. It also bears pointing out that Annex 1 of INSAG 7 is very unequivocal about the mere act of shutting the reactor down, rather than the rundown test preceding the shutdown being the real initiator of the power runaway and subsequent explosions. With violations 2 and 3, we get into some proper masters of weaponized narration territory, where we see subtlety employed to an amusing effect. The stars of the show are half-truths, or seemingly true statements that contextually turn into stunning lies. Case in point, the statement written under violation number 2 is actually a true statement in and of itself. The power level was, in fact, well below the level provided for by the test program. Note how vague the consequence is, too. Reactor proved to be in a condition difficult to control. We actually take issue with this statement, as one of the things Soviet experts did was play up any apparent instability, but the vague quality of the statement makes it more difficult to argue against. So what are the contextual issues these claims ran into? When you're listing the most dangerous violations of the operating rules committed by the staff that are supposed to account for why a nuclear reactor blew up, violation number 2 cannot be exclusively found in a test program, meaning it should also be found in general safety rules, especially when it concerns something as generic as the power level of the reactor. A few paragraphs above the table of violations, the Soviet report even mentions reactor rules are concerned. Likewise, what exactly is the consequence of a low power level? Why was a low power level dangerous, and how did the reactor designers and scientific overseers intend to avoid the associated dangerous conditions in general? As opposed to, per se, lying in writing, Soviet experts passed this formal form of lying to their international counterparts who wrote INSAG 1. Observe how violation number 2 transforms between the Soviet report to the Vienna meeting and the international report that resulted from the Vienna meeting. On pages 3 and 77 of INSAG 1, the following paragraph is featured. At the first level, one should look for inherent stability. At equilibrium fuel irradiation, The RBMK reactor has a positive void reactivity coefficient. However, the fuel temperature coefficient is negative, and the net effect of a power change depends upon the power level. Under normal operating conditions, the net effect, power coefficient, is negative at full power and becomes positive below approximately 20% of full power. The operation of the reactor below 700 megawatts thermal is restricted by operating procedures owing to the problems associated with maintaining the thermal hydraulic parameters in their normal operating range. Let's keep going because this is literally as important as it gets. Operation at unacceptably low power levels. Following the power reduction, the reactor power fell significantly below the minimum permitted level for continuous operation, 700 megawatts thermal, owing to incorrect control system transfer. This level is set to avoid the reactors being operated in a condition where an increase in power results in a still larger power rise. The larger the void coefficient and the lower the power level, the stronger is the effect. The experiment should have been terminated under these conditions. Page 15 provides a crystal clear claim of where a lower power limit of 700 megawatts was supposed to be set. Note that continuous operation below 700 megawatts thermal is forbidden by normal safety procedures owing to problems of thermal hydraulic instability. Then page 16 provides a similarly clear definition of the consequence. The parameter that governs overall stability, the power coefficient, this is the parameter which, if not compensated for, may provide a dangerous amplification of any small power perturbation. The positive power coefficient of reactivity, not to be confused with the positive void coefficient of reactivity, was so important in SAG 7 on page 16, reduces in SAG 1 and the efforts of Soviet experts in terms of it. In SAG 1 repeated the view stated in the Soviet presentation, that a major reactivity-induced transient made possible by the positive power coefficient had been the primary cause of the accident. On page 19, INSAG 1 explicitly reframes the power figure found in the testing program. This level was chosen to be above the minimum allowable operating power of the reactor. The power coefficient of reactivity is the sum of other coefficients of reactivity, including the void coefficient. When the power coefficient of reactivity is negative, a reactor has a self-regulating quality in that reactor dynamics oppose changes in power. When the power coefficient of reactivity is positive, a reactor has a runaway quality, as reactor dynamics amplify changes in power. A runaway quality of a nuclear reactor is a very bad thing indeed. And this was not lost on the Soviets. Page 35 of INSAG 7 cites a design rule that was present from the beginning of RBMK reactor operation. Article 3.22 of NSR 0474, as well as Article 2.23 of GSP 73, states that, when designing the reactor, it is desirable to ensure that the total power coefficient of reactivity is not positive under any operating conditions. If the total power coefficient of reactivity becomes positive under any operating conditions, the nuclear safety of the reactor during steady state, transient, and emergency operating conditions must be guaranteed in the design and explicitly proved. After the 3 Mile Island incident in the United States, the Soviets went further, updating this rule to exclude a positive power coefficient under any circumstances. Inside the Politburo, Boris Shabina cited the updated design requirement. According to the safety requirements, the power coefficient must not be positive in any, even extraordinary, situations. So between the Soviet report to the Vienna meeting of 1986 and INSAG 1, the power level found in the testing program related to the reactor being in a condition difficult to control evolved into the most important rule of general RBMK reactor operation found in normal safety procedures. And you would figure at the hecking top, plastered on multiple pages, the consequence of which was preventing RBMK reactors from running away, and it is not much of a stretch to say exploding. That 700 megawatts. Now, would you be surprised to hear that this was all BS? Behold the bottom of page 10 and the top of page 11 of INSAG 7. 2. Minimum allowable operating power of the reactor, 10 minutes past 11, 25th of April. The statement made in INSAG 1 that continuous operation below 700 megawatts thermal is forbidden by normal safety procedures owing to problems of thermal hydraulic instability was based on oral statements made by Soviet experts during the week following the Vienna meeting. In fact, sustained operation of the reactor at a power level below 700 megawatts thermal was not prescribed either in design, in regulatory limitations, or in operating instructions. The emphasis placed on this statement in INSAG 1 was not warranted. So Soviet experts blatantly lied orally during the week following the Vienna meeting. Our reading of INSAG 1 suggests what happened here. In the foreword of the report, it is stated, a large number of experts from agency member states and from other international organizations participated in the discussions at the meeting, receiving from Soviet experts detailed information on the accident and contributing from their own experience to the discussion of specific issues and to the formulation of proposals for follow-up actions. During the week after the meeting, INSAG and associated experts prepared, as I had requested, this report, with the help of IAEA-nominated experts in the wide range of nuclear safety and radiation protection disciplines involved, and of several Soviet experts made available to INSAG. Intense discussion among the experts during this one-week period led, as stated in the INSAG report, to a clearer picture of the evolution of the accident and its consequences that is reflected in the report. On page 75, a continued effort by international experts to clarify what happened despite the positive reception of the Soviet presentations and report is also mentioned. The Soviet report was thorough and professional. The frank and open presentation by the Soviet participants in the meeting were well received by other participants, who responded to the Soviet experts with hundreds of written questions. Most of these questions were requests for further details and quantitative answers on technical issues, which would require further investigation and examination. Undoubtedly, additional and firmer details are expected over the coming months and years. INSAG has reviewed the report made to the post-accident review meeting by Soviet experts, and INSAG members have had further discussions with the Soviet experts. The INSAG view is that the course of events described as having taken place is entirely plausible, and it is consistent with the understanding of how such systems might be expected to behave under the factual conditions described. This is not to say that questions do not remain, and Soviet experts are among the first to agree with this conclusion. So it appears, if INSAG 7 is accurate in attributing the lies related to the power level to oral statements by Soviet experts during the week after the meeting, that at some point in subsequent discussions, someone, or some people, pressed Soviet experts to clarify the meaning of violation number 2, under scrutiny of which half-truths that perhaps made sense at a surface level needed to become full-blown lies to actually make sense. In case you're wondering when the power coefficient of reactivity became positive in RBMK reactors, page 36 of INSAG 7 claims that the power coefficient of reactivity was positive at power levels greater than 50% of the nominal level, which was 1600 megawatts, or more than twice as high as the 700 megawatt power level found in the testing program. Moreover, there was a lack of calculations of the coefficients of reactivity at power levels under 50%, or 1600 megawatts, which led the authors to conclude that Soviet nuclear power experts evidently did not expect any dangerous characteristics in the behavior of the reactor at low power levels, and notes that they did not impose any restrictions on reactor operation at low power levels before the accident on the 26th of April 1986. In fact, it's somehow slightly worse than that. On pages 76 and 77, in a brief discussion on there having been no 700 megawatt rule in the design documentation, the regulatory documentation, nor the operating documentation, it is mentioned that in certain circumstances the operating procedures actually required operators to reduce the power level under 700 megawatts, and there was no limitation on for how long low power operation could last. The masters of weaponized narration were particularly adept at shifting their own spectacular failures onto their hapless subordinates and inferiors, while making it look like they weren't even lying in their own report. Admittedly, that is rather impressive. The third violation is what we call the 2-for-1 Soviet bundle. You can immediately tell something's not quite right when within what is supposed to be a violation, there is a violation. Violation number 3, connecting all of the main circulation pumps to the reactor, with individual pump discharges exceeding the levels specified in the regulations. This was not accidental. In order to fully understand what is happening here, we need to simultaneously keep in mind what the listed consequence is. Coolant temperature in the multiple forced circulation circuit approached saturation temperature, or, in the words of INSAG 7, the temperature of water at the core inlet was close to boiling. Just as with the previous violation, the word game Soviet experts were playing in their own report resulted in a blatantly false statement featured in INSAG 1, as international experts were running their Soviet to English translation. As if we're appreciating the work of a great artist, let's take another look at what Soviet experts were putting down in writing, this time a few pages earlier in their report on page 16. Since the reactor power, and consequently the hydraulic resistance of the core and the MFCC, were substantially lower than the planned level, and since all 8 main circulation pumps were in operation, the total coolant flow rate through the reactor rose to 56,000 to 58,000 meters cubed per hour, and at some individual pumps to 8,000 meters cubed per hour, which meant a violation of the operating rules. An operating regime of this kind is forbidden because of the danger of pump breakdown and the possibility of vibrations arising in the main coolant pipes owing to cavity formation. Normal people not initiated in the art of deception would take the statements we have been reading to mean what is plainly stated on page 15 of INSAG 1. The high flow rate created by these extra pumps was a violation of normal station procedures, since it exceeded approved levels both for the reactor core and for certain individual pumps. So, according to INSAG 1, there was a double violation of both flow rate for the reactor core and of flow rates for individual pumps. But normal people aren't Soviet nuclear power experts after a Soviet RBMK core explodes. What is going on here? We go to page 77 of INSAG 7 for a reveal. At 103 and 107, in accordance with section 2.12 of the testing program, one main circulation pump from each side, MCPs number 12 and 22, were also switched on to cool down the reactor during the test. Before 26th of April 1986, no document, including the operating procedures, prohibited connection of all 8 MCPs to the reactor at any power level. In the Commission's view, the personnel committed no violations by these actions. At the same time, at low power levels, when the feed water flow rate is less than 500 tons per hour, the operating procedures limited the capacity of each MCP to 6,500 to 7,000 cubic meters per hour in order to prevent cavitation. On the 26th of April 1986, the flow rates of certain MCPs actually exceeded the limit, violation of section 5.8 of the operating procedures, but did not cause cavitation of the pumps, as is evident from the DREG program printout, and is confirmed by the studies carried out by the Mechanical Engineering Experimental Design Office and other organisations. Reference 31 points out that both the pumps being run down and those not being run down maintained at a steady water supply, even during the runaway and destruction of the reactor. The connection of 2 additional main circulation pumps was not a violation. There is also not a single mention in the entirety of INSAG 7 of a violation of a total flow rate. The total flow rate was high, but no violation is associated with it. A violation did occur in excessive flow rates of individual pumps, but the consequence associated with it, cavitation and pump breakdown, did not occur. Do you remember that the listed consequence in the Soviet table of violations was that water was close to its boiling point? On pages 7 and 8, the international section of INSAG 7 attempts to explain how the individual pump flow limits were implicitly meant to lower the coolant temperature. Yet it does not account for the fact that the flow through 2 additional main circulation pumps made a greater contribution to the total flow rate that was relevant to the temperature of the coolant. In his article, How It Was, An Operator's Perspective, Deputy Chief Engineer of the Chernobyl nuclear power plant at the time of the disaster, Anatoly Dyatlov, notes that the connection of 2 additional main circulation pumps was not only not forbidden, but explicitly allowed by operating instructions at the time. The carrying out of the test called for in the TG rundown program also had no influence on the occurrence of the accident. The experiment required no special operating conditions at the plant. 4 main circulating pumps, MCP, in each of the plant's 2 loops were to be operated instead of the usual 3 per loop. But such operating conditions occurred frequently during pump tests, after repairs for example, and were included in the operational instructions. Dyatlov does not stop there. In his other article in response to some parts of INSAG 7, titled Why INSAG Has Still Got It Wrong, Dyatlov points out that the very consequence itself, water being close to its boiling point, was included in operating instructions. At the time, as an inherent part of RBMK operation, and was explicitly allowed. The reactor is operated only in boiling mode and, according to the regulations, may be operated with minimal or even zero subcooling. See Regulations, Chapter 9. This condition is obligatory, since such operating conditions cannot be avoided in principle. They occur with any rise in power, when the pressure falls in the separators. Remarkably, there is support for this statement in Annex 1 of INSAG 7 on page 64. The thermal hydraulic operating conditions of the core were characterized by a low level of subcooling of the coolant below the boiling temperature, 3 degrees Celsius, and a correspondingly low steam quality, which was observed only in the upper part of the core. Under these circumstances, in view of the low level of subcooling of the coolant below the boiling temperature, a small power increase, for whatever reason, could result in a much higher increase in the volumetric steam quality in the lower part of the core than in the upper part. Before the tests, the core parameters were therefore such as to increase the reactor's runaway susceptibility in the lower part of the core. The Commission believes that this situation was created not only as a result of a higher than normal flow rate of coolant through the reactor, because 8 instead of the usual 6 MCPs were in operation, and an increased flow rate prevents steam generation, but primarily as a result of the low reactor power level. Similar thermal hydraulic parameters could occur during any power reduction of the reactor. In essence, Soviet experts bundled a non-violation of arguable consequence with a violation of no occurring consequence, to make it seem like operators did something wrong of terrible significance to the disaster, all while making true statements in complete isolation from any context. Half-truths at their finest. If this makes no sense to you, that's probably because you're no master of weaponized narration. It is only when you try to reason through their statements that the ridiculousness of what they were doing emerges. People who only think they reason well are apparently what the Soviets used to refer to as useful idiots. The bottom half of the violations table corresponds to the switching off of a number of important protection systems that the operators were not supposed to have done to disastrous consequence. With these, we'll encounter another notable aspect of Soviet deception. the changing of timings and narrative dramatization. You don't need Western entertainment writers to dramatize your narrative when you've got Soviet nuclear power experts looking for control room scapegoats after a nuclear power disaster. Violation number 4 is blocking of reactor protection system relying on shutdown signal from 2 turbo generators. In other words, there was an automatic shutdown upon disconnection of both turbines that the operators blocked. The consequence was loss of possibility of automatic shutdown of the reactor. This loss of possibility phrasing is even more reserved on page 17 of the Soviet report, where the framing reads, "This meant a further departure from the experimental program, which did not call for blocking the reactor's emergency protection with the switching off of 2 turbo generators." Once again, we rely on INSAG 1's Soviet to English translation to clearly inform us of meaning. This trip would have saved the reactor, and once more on page 24. The reactor trip on loss of the second generator was switched off to allow a repeat of the test if needed. This was a key violation of the test program, since the reactor would have safely shut down when the test began, even with the rod configuration existing at the time. This is much clearer, isn't it? So why did Soviet experts have such difficulty spitting it out in their report? As usual, we head to INSAG 7 for the reveal. And as usual, it does not disappoint. 4. Turbo generator trip signal blocked, 12304, 26th of April. Both the time and significance of the blocking of the turbo generator trip have changed in the light of new information. The event occurred at 004327, rather than 12304 as stated in INSAG 1. The time at which the second turbo generator was shut off remains unchanged. This trip was blocked in accordance with operational procedures and test procedures, and the SCS SIMP Commission, Annex 1, Section 1 to 4.74, does not support the appointment of any blame to the operating personnel. In the light of new information regarding positive scram, the statement made under the significance column of Table 1 in INSAG 1 that this trip would have saved the reactor seems not to be valid. Ouch. For good measure, let's include a statement on page 18 as well. Disabling of the 2-turbine trip was allowed, and indeed was required by normal procedures at low power levels, such as the power level for the revised test. In any event, the occurrence of this trip might well have caused the destruction of the reactor at the time of the turbine trip, rather than shortly afterwards. There are a number of things going on here. 1. Somehow, the time of the event was off by 40 minutes. If we are to jump to page 76 of INSAG 7, we find that what prompted the event was amply documented, to say the least. According to operating logs of the plant shift supervisor, the unit shift supervisor, the electrical workshops shift supervisor, and the senior turbine control engineer. Looking at my fingers, that's a whopping 4 operating logs. We will come back to this later. 2. The protection system was blocked, not in contradiction of, but in accordance with the operating instructions. The paragraph on page 76 of INSAG 7 mentions something that is absent from both the Soviet report to the Vienna meeting and INSAG 1, a separate test program for the measurement of turbine vibrations, which, incidentally, was important to complete because apparently in saving metal in the forging of newer turbines, an operational imbalance was introduced, and the only equipment suitable for the task was riding in the back of a certain red Mercedes truck. This separate test program was supposed to be completed at half power, with alternating loads between both turbines, but apparently due to yet another issue, its completion was pushed back. Without turbo generator number 7 being available, that meant turbo generator number 8, in essence, had another rundown test, which meant that in order for both remaining tasks to be completed, the reactor had to keep running, and the automatic shutdown upon disconnection of both turbines had to be disabled. The operators did nothing wrong in disabling this automatic shutdown, as at a low power level, or a low turbine load, not enough steam was being consumed by the running turbine for a problem to occur upon its disconnection, and the operating instructions permitted the switching off of this protection. Of course, Soviet experts knew this. They could not discuss any of it, as much of their narrative would have collapsed. For a longer discussion on this topic, refer to the unanswered questions. Why did the power level decrease under 700 megawatts video? Third thing going on, rather than saving the reactor, this automatic trip at 123.04 would have likely exploded it about half a minute earlier. Using the disabling of this trip as a violation against the operators only made sense in a pre-positive scram effect context or narrative. As page 13 of INSAC 7 informs us, it took Western analyses of provided data for the positive scram effect to gain public prominence, and for the Soviets to admit something they had already been all too aware of. Contrary to the popular understanding of Chernobyl, the positive scram effect was just the tip of the proverbial iceberg in terms of what Soviet experts were hiding and lying about. Violation number 5 is blocking of protection systems, relying on water level and steam pressure in the drum separator, with a consequence of reactor protection system based on heat parameters was completely cut off. A few pages earlier, the Soviet report to the Vienna meeting elaborated. The switching in of the additional main circulation pumps and the resulting increase in water flow through the reactor brought about a reduction of steam formation, a fall in steam pressure in the drum separators, and changes in the other reactor parameters. The operators attempted manually to sustain the main parameters of the system, steam pressure and the water level in the drum separators, but they did not entirely succeed in doing so. At this stage, they saw the steam pressure in the drum separators sag by 0.5 to 0.6 megapascals, and the water level dropped below the emergency mark. In order to avoid shutting down the reactor in such conditions, the staff blocked the emergency protection signals relating to these parameters. INSAG 1 picks up on something central to the impression Soviet experts sought to create. On page 24, the report mentions that even a major violation like continuously operating the reactor at 200 megawatts, something that was supposed to be forbidden but turned out to be a lie instead, was alone not enough to have caused the accident. Later actions compounded the problem. In other words, Soviet experts sought to convey that they followed the defense in depth principle, putting multiple hurdles in front of a severe outcome. Soviet experts sought to portray the Chernobyl operators as willfully committing major violation after major violation, only the extremely improbable confluence of which was sufficient to blow up the reactor, so as to absolve themselves of responsibility. Soviet experts needed to string together several egregious violations with multiple off-ramps for the operators to have avoided the disaster, had they not been complete imbeciles. When we previously read from the bottom of page 15 of INSAG 1, we cut off the following sentence fragment with respect to the alleged main circulation pumps violation. More importantly, it made control of the main coolant systems difficult. Page 16 continues. One important consequence was that the operators disabled the reactor trip on separation drum level and steam pressure to ensure that the fluctuations did not cause such a reactor trip and stop the test. Again, a serious violation of a normal station procedure. So, the connection of extra MCPs was significant, not only in itself, but as a link to the next egregious violation of normal station procedure, the disabling of another automatic shutdown system. By 1:19 on the 26th of April, the steam drum level was still hovering near the emergency level. Since the operators were having trouble with pressure and steam control, they switched off the reactor trips associated with these parameters. So, a few minutes before the explosions, the operators again switched off a shutdown, even multiple shutdowns, that would have saved the reactor. As if by a miracle, INSAC 7 reveals that the switching off of this protection system was also inexplicably mistimed by about 40 minutes. Steam level protection disabled, 1:19, 26th of April. The recent information suggests that the steam drum protection was changed as early as 36 minutes past midnight on April 26th, and not 1:19, as stated in INSAC 1. However, according to Annex 1, sections 1 to 4.7.4, contrary to what is stated in official documents, the SCS-SIMP Commission does not consider that personnel should be held to blame for having blocked the steam pressure protection system of the steam separators. The details here are apparently a little too much for the international section of INSAC 7 to handle. So, before we go delving into them in Annex 1 of INSAC 7, we are going to give our answer to a question INSAC 7, and seemingly everyone else, hasn't bothered asking, let alone answering. How and why were two critical events, the disabling of automatic shutdowns related to the disconnection of both turbines, and to certain steam separator parameters, that were supposed to have occurred within a few minutes of the disaster, mistimed by about 40 minutes? Recalled from the start of this onerous video imposing unreasonable demands on your reptile brain, writer Adam Higginbotham's inadvertent casting of Valery Legasov as a campfire storyteller masterfully holding his audience spellbound. Legasov described a minute-by-minute reconstruction of the accident sequence, far more terrifying than any of the Western experts had imagined. Legasov's scary story was an intentional fiction. The two mistimed switching offs of automatic protection shutdowns were a crescendo in Legasov's narrative. After all the Chernobyl operators had done, when the danger of their actions was becoming evident even to themselves, if they had just allowed one of two, or even three, protection systems to shut down the reactor, a historic disaster moments later would not have occurred. The slate could have been wiped clean, and all would have been well, if not for multiple more missteps at the door of catastrophe. The reality was Soviet experts were dramatizing their own narrative, underscoring a fiction of a series of unforgivable violations against all odds. If they had to explain the non-fiction of how a nuclear reactor explodes to contaminate swathes of Europe, and especially a Soviet region, because its operators pressed its shutdown button after following its normal station procedure, they would have had a tale to tell far more improbable than most people could imagine. One as farcical as it would be terrifying. Instead, we return to our little examination of their lies. Annex 1 of INSAC 7, from the bottom of page 74 to the top of page 76, explains the steam separator drum parameters situation in adequate detail. First, there is a distinction between the water level in the steam separator drums and the steam pressure. The water level protection worked by the operators having had to switch on protection at a different level. In other words, they avoided an automatic shutdown being triggered by not switching on the protection at the particular level, rather than by switching anything off. Accordingly, it was false of the Soviet report to the Vienna meeting to claim that all the thermal parameter reactor protection systems were switched off, as it did in the consequence column of this violation. Furthermore, Annex 1 of INSAC 7 proceeds to clarify that the operators did not straightforwardly commit a violation in not performing the protection level switch. Page 75 continues. The designers made it clear in reference 43 that automatic reswitching of the set points of EPS1 and EPS5 during emergency fluctuations of the water level in the steam separator drums is not permitted, since during operation of any of the emergency protection systems, 1, 2, and 3, the water level falls to the minus 600mm set point on the instrument, which has a range of plus 400 to minus 1200mm. This, in turn, will result in actuation of EPS5 and complete shutdown of the reactor. They found an extremely simple way out of this. Instead of automatic reswitching of the set points and automatic deactivation of EPS5 in response to a reduction in the feed water flow rate, the operator should reswitch them manually using the general key when the alarm signals appear. It is not for us to demonstrate the feasibility of solving this problem using engineered safety features. This is feasible, but rather to demonstrate that in cases where there was a choice between complying with the safety requirements and shutting down the unit, or giving priority to economic considerations in keeping the unit in operation, the choice used to be made in favour of the second alternative, with the functions of the emergency protection system being transferred to the operator with a deep faith in the operator's complete reliability as a component of the safety system. What does this mean? It means that the designers of the reactor could have included an actual automatic shutdown protection system based on this parameter, but did not do so intentionally. They did not want the reactor to shut down every time the particular emergency water level was hit. Instead, they left it to the judgment of operators to, in essence, manually shut down the reactor by switching the protection level, an action for which they might have had to answer as well. It is very easy to interpret this as it was up to the operators to control this parameter, even after it hit the particular level, before resorting to a shutdown. There is something else to point out. If you look at the top of page 54 of INSAG 7, you can see there were 6 emergency fluctuations of water level in the steam separator drums. 4 of these fluctuations occurred before the connection of the main circulation pumps. According to the 1986 narrative, it was supposed to be the switching on of the extra main circulation pumps and increasing instability in close proximity to the explosion as a result of the operator's growing string of violations that caused the emergency level to be hit and the automatic protection to be disabled. Such instability was itself either fiction or overplayed. A paragraph on page 64 suggests the dramatic instability aspect was an anachronism, a misleading part of the narrative conveniently inserted after the reactor exploded. The paragraph reads, "During the period from the beginning of the power rise to stabilization of the reactor, parameters at 200 megawatts at about 123, normal technical processes and operations were taking place at the unit, except for the switching on of the 4th main circulation pump pair. These included triggering of the fast-acting system for dumping steam to the condenser, manual control of the water level in the steam separator drums, overcompensation of the reactor, etc. Actions like manual control of the water level in the steam separator drums, overcompensation of the reactor, etc., were normal technical processes and operations, not frantic violations of operators careening towards disaster. The matter of steam pressure in the steam separator drums was simpler. The operators changed a set point they were allowed to change at 36 minutes and 24 seconds after midnight, rather than at 1:19 am. Furthermore, this protection system could only stop the turbine. This was basically a non-story. Last and least, we arrive at violation number 6, switching off of the emergency core cooling system, with a consequence of loss of the possibility of reducing the scale of the accident. Even INSAG 1 on page 23 catches the direct irrelevance of this table stuffer. During this period, the ECCS remained isolated. Although subsequent events were not greatly affected by this, the fact that the ECCS was not reset reflects the attitude of the operating staff with regard to the violation of normal procedures. According to morning shift supervisor Igor Kazachkov, even Soviet experts at the trial of Chernobyl personnel and management admitted the disconnection of the emergency core cooling system had no effect on the disaster. The international section of INSAG 7 tries to reframe the disconnection of the ECCS as simply indicative of an absence of safety culture in the simple absence of any other argument to be made. 1. Isolation of the emergency core cooling system. 2 p.m, 25th of April. It was stated in INSAG 1 that blocking of the emergency core cooling system, ECCS, was a violation of procedures. However, recent Soviet information confirms that blocking of the ECCS was in fact permissible at Chernobyl if authorized by the chief engineer, and that this authorization was given for the test leading up to the accident and was even an approved step in the test procedure. INSAG believes that this point did not affect the initiation and development of the accident. However, it must be recognized that the plant was being operated at half power for the period of approximately 11 hours leading up to the accident, with the ECCS blocked out. This could be viewed as no violation only if the 11-hour period of half power operation were part of the planned test, which it clearly was not. Blocking the ECCS over this period and permitting operation for a prolonged period with a vital safety system unavailable are indicative of an absence of safety culture. Clarifying context on this matter is provided by day shift supervisor Yuri Tregub. The ECCS, Emergency Reactor Cooling System, began to be removed on Kazachkov's shift. This is a very big job. We have manual fittings. Just imagine, one bolt takes about 45 minutes. The valve is like the steering wheel on a sailboat, only a little smaller and stands horizontally. To close it, it requires the effort of 2 people, or better yet, 3. This is all done manually. Kazachkov needed almost the entire shift to bring out the emergency system. It's very hard work. How long would it take me to reintroduce it? I wouldn't introduce it. What if we had to take her out again for testing? By the way, as the course of the accident showed, the ECCS would not have given anything anyway, because all the connectors flew off. Everything flew off, all the valves at once. Nikolai Steinberg, the chairman of the commission that produced Annex 1 of INSAG 7, summarizes the lies of Soviet experts in a book he co-wrote titled Chernobyl Past, Present and Future, as follows. Familiarization with the materials presented by the USSR in 1986 to the IAEA, the Chernobyl accident and its consequences, information prepared for the meeting of the IAEA experts, August 25th to 29th, 1986, Vienna, was shocking. The personnel actions which complied with the regulations were presented as their violations. The restrictions of the regulations introduced after the accident were represented as valid before it. What happened here is clear. Soviet experts deliberately scapegoated Chernobyl's operators, crafting an extensive, even comprehensive, false narrative as their weapon. The man who was publicly most associated with the misleading narrative as at minimum its mouthpiece, first deputy director of the Kurchatov Institute, Valery Legasov, is ironically remembered as a hero by many people. These people are under an ignorant impression that the tapes Legasov recorded sometime before his death set the record straight. They didn't. On side A of tape 4, we find the following statement that speaks for itself. Of course, the mistakes made by the operators are well known, and there is no need to list them yet again. These mistakes themselves are monstrous. The actions of the station management are very hard to explain. Punishing the direct culprits of this disaster is correct, because the actions did not meet regulatory requirements and showed inconsistency with the job requirements of the people who were acting in this situation. This statement leaves us with a question. Since Legasov himself claims to have been no reactor expert and found traditional reactor engineering rather boring, was the first deputy director of the Kurchatov Institute of Atomic Energy perhaps himself a victim of the masters of weaponized narration, tricked to speak falsehoods he had no idea of? Nikolai Steinberg's co-author of Chernobyl Past, Present and Future, Georgy Kopczynski, has a striking recollection. Kopczynski was head of the sector of nuclear power industry of the Central Committee of the Communist Party of the Soviet Union. In particular, Kopczynski claims that not only was he a member of the Central Chernobyl Task Force the Soviet government created, but was also responsible for keeping minutes of speeches and remarks personally. Kopczynski recalls the following event on page 60 of the book. But it was stated in Valery Legasov's report at the task force meeting that the personnel alone were at fault in the accident. However, there was a reservation concerning some negative RBMK 1000 properties, but as if incidentally, without any specifics and necessary explanations. The materials prepared by Valery Legasov's group appeared in the Heavy Industry and Energy Division of the Central Committee, a few days before the described meeting of the task force. We urgently prepared a corresponding report in which reasoned the fallacy of Valery Legasov's group's interpretation of the accident causes. But only Dolgy supported our report at the meeting of the task force. Valery Legasov's thesis were approved without much discussion. During the report, I could not contain my emotions. Legasov saw my reaction. After the meeting, he came to me. Ryzhkov, Ligachev, and Alexandrov continued sitting at their places, and I think heard our conversation. I gave Legasov reasoning against proposed by him interpretation of the accident causes. I added that we consciously misinformed the world community, and that misinformation will be short, since a few design researchers would be enough to clear the true picture. Authority of the state would be affected. Legasov listened to me, squinted in the direction of Ryzhkov, who was Premier of the Soviet Union and apparently a Legasov ally, did not answer, and went away. Alexandrov kept silent. There was no reaction from Ryzhkov and Ligachev. Finally, let's circle back to Craig Mazin and the HBO Sky miniseries. Mazin appears to have been aware that INSAG 7 made corrections to the former narrative. But ironically, while he excluded some individual Soviet expert lies, he preserved the collective point of lies. That the operators, in his mind, solely in the caricature figure of Anatoly Dyatlov, bore much of the responsibility for the disaster. Mazin seemingly made up his own bizarre version of the sequence of events leading up to the explosions, centered on constant and inexorable xenon poisoning, the unscientific nature of which we have touched on in other videos, and we will touch on again in at least one future video. But it bears repeating how, with ill intent, and even a bias against the Soviet system, along with an awareness that you're dealing with lies and liars, the creator of the miniseries, not to mention the other creatives involved in the conception and realization of this mis- and disinformation disaster, and its audience of millions, were ironically duped by the masters of weaponized narration to vilify Dyatlov and glorify Legasov, along with the scientific establishment that bore the brunt of responsibility for Chernobyl. In other words, Craig Mazin and his team managed to put out their own popular and successful version of Soviet propaganda over 30 years after the disaster, with the truth being openly accessible. That, right there, is a testament to mastery of weaponized narration. We leave you with some words from HBO Sky Chernobyl Valery Legasov. What is the cost of lies? It's not that we will mistake them for the truth. The real danger is that, if we hear enough lies, then we no longer recognize the truth at all. And for good measure, let's leave you with some even more words from HBO Sky Chernobyl Valery Legasov, as the man was on an absolute roll. To be a scientist is to be naive. We are so focused on our search for the truth, we fail to consider how few actually want us to find it. But it is always there, whether we can see it or not, whether we choose to or not. The truth doesn't care about our needs or wants. It doesn't care about our governments, our ideologies, our religions. It will lie in wait for all time. And this, at last, is the gift of Chernobyl. Where I once would fear the cost of truth, now I only ask, what is the cost of lies?